Hello everyone, welcome to the last video. So in this video we're going to be evaluating if in context is helping, and so we're going to be talking about this picture for a little bit and then head to the code. So in the code I have three loops. I have an outer loop, middle loop, and inner loop. And in this outer loop I am sampling, uh, I'm getting initial sampling from some randoms range, so from negative pi to pi for theta and then negative 10 to 10, and then I calculate RK4. So pretty much the outer loop is creating these new lines here. So I'm testing at 4 different lines, and then number of points is how many different points I want to test out. So here for this one specific line, so these are all the same lines, is I'm testing out 3 points, so 45, 80, 75. For the next iteration or the second iteration of the outer loop, I get this line. I'm testing instead of 3 now 2 points, so it's 55, 65. And then the next iteration I get this line, these lines, and I'm testing all these points here and at different starting index here, and yeah. And so that's what that's doing. Number of points is how many points I want to test out, and the point value range is what starting points I want to test out here. So that's what that is. And things that stay constant is the number of in context. So this stays constant because I'm going to be adding all these. So at one here, one here, one here. I'm adding here, 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 and also at one here. So there's no context, no context here, here. And so let's see what these lines are doing. These lines, so these all starting points are all the same. It's actually overlapping here. The only reason why I didn't put it like that is because then it'd be hard to see. So I just spread it out. But just know that these are all this at this point, starting point. So, so at this point there is no in context, and so from this point, all these times are the same as well. It all ends at 90 states, 90 states, 90 states, 90 states. All these here at the end just goes up to 90 states. And so yeah, I get this line here, and then the next one I'm testing one in context. So I add an x and a y from the RK4 to give to the model, and then I start getting the next state from the U prediction done here, and then another one, another one, another one, until I hit 90 states. And then this is 2 in context, and then it does the same. 3 in context does the same. And here what I'm doing is calculating the total energy um, for each one. So there's without context, with one context, 2, 3, etc., all the way to 20. And I'm putting them to the correct index here. So at 0, which is 0 in context, is 3.3. Then it's 3.2, 3.3, 3.1, all the way to 20. I didn't put anything for 20 because there's too many dots and lines here. And so that's that 45. And then for the middle loop, then I go to the next one in the middle loop, which is 80. I start here now. Do the same thing, 1 context, 2 context, 3 context. And then from this starting index, I calculate the total energy. So it's 0.2, 3, 0.1, 0.1. And then I go to that last one in the middle loop, which is 0.75, which is here. Actually, it's not 90 states. Here I put 85 states because it's 80 to 5, 85. And then 30 to 55 is 85. Okay, so in this picture it's 85. But here is 75, starting at 75 index, and then the same thing in context, and then calculating total energy. So 1.5, 1.5, 1.6, 1.7. And so that's one whole iteration of the outer loop. And then for the second iteration, I get a new sampling here for the starting state, and then create the RK4, which is a whole new line. And I do the same thing. I see how many points this is going to test out by doing random, and then it gave me 2 here, and then the point range is also about random, so now it's 55 and 65, so it's testing point here to the end, and then one in context, but it's just getting the values from here to the end, etc., etc., and adding all these to the correct index correlated to their context that I'm using, and then the same for here. And then there's this whole one where now it's 5 points, and these are the ranges or values here. I just didn't add it here because it's just the same thing. I ran out of space. And this is valid. So I'm keeping this constant because let's say I did right here at point 2 or starting index 2. Well, starting index 2, yeah, so if I did at point starting index 2, let's see. Yeah, so it'd be just up to 2, right? Because I can only add 2 in context before it, and then all these numbers are going to be way different. So these 2 are going to have more energy, just for the fact that I am calculating more total energy sent for more points. And yeah, that's why also here I don't include these here, because if I include these, then the total energy is going to be way bigger for these. So that's why I state them constant, and I choose an index where it's less than 20, or where it's more than 20, so I could allow 0 to 20 contexts. And this is also valid. So this is all 40 points. So for this whole row, it's 40, 40, 40, 40, etc. This one's 5, so it's 5, 5, 5, 5, and then 10, 10, 10. And to the same is, uh, uh, I guess these got mixed up. This should be 20 up here. This should be 30. But yeah, but overall, all of these points, once I added them, they all have the same number of points. So it's going to be 105, 105, 105, 105. So the total energy is for the same number of points. Um, and yeah, so that's what's making it valid. There's no context that has more points getting calculated for total energy. And yeah, so let's go through the code. So this is the code here, and we're just going to go over it. And here are some things to know. So min start has to be more than 20, since I need at least starting index to be 20 um, in order to be able to test 0 to 20 in context. And 85 is that upper limit, so I have a total of 90 time steps, so 85 was what I chose, so I can at least test total energy for 5 if 85 was chosen. Let's see, so I am making 64 lines here. And for the number of indices, so I want to choose as many unique points as possible. So so that's what the upper range of the number of indices is. Yeah, that's the upper range of the number of indices I can use. So let's say I've gone through 30 numbers and there's only 20 numbers available, then it's from 2 to 20, the length of the number of points I want to choose. And so once there's less than 2 numbers available, then it resets the sampling pool from there, but still all random, and yeah. So here I get that initial starting point where I use random, right? Negative pi to pi, negative 10 to 10 for the outer loop. And where were we? Yeah, this is where I get the RK4. And the only reason why I use RK4 is because of in context examples if I want to give it. So if it was no in context, then there's no point in doing RK4, but I am adding up to 20 in context. And so I'm just saving all these numbers to a file. And here is, yeah, I'm just putting it into the form so I can pass it into the model here. And yeah, this is where the middle loop starts here. So it's iterating through these indexes here. So it's going to be at the 40th 5 point, 20th starting index, 75 starting index. So that's what that is. And then the context, so this is all 0 to 20, since it's a 20, it's a constant number here. And yeah, this is where I pass it to the model. This is where I run inference on the model, and we can check it out. Yeah, I'm using CUDA. Start index is passed here. Total time is incrementing by 0.01, and that's because with 0.1 it stabilizes too quickly, so I use 0.01 better. So end steps should be 90, and what this is doing here, I am just adding, so I'm just getting it from that start index that I pass all the way to the end. And let's say I'm doing 1 in context, so instead of passing just 20 to 90, it's going to be now 19 to 20, because I'm giving it that previous example. And here I am passing it to the model, and I am just getting the second to last, just because it's interweave with x and y, so it's x, y, x, y, x, y, and I just want to keep that last prediction x did. So that's why I did -2, and here is, so I'm using RK4 with that new u that I get here to get the next state. So that's what I'm doing there. I get the new x, and then I save it to x data context. So now the model will see, let's say it was only no context, so initially it only had 1, but now that I added it to x context, now it has 2 points. So that starting index and then that new predicted index, and it keeps adding and adding and adding until I hit that 90th time step. And then even for a new y, so with y, I am also adding it to view it, but yeah, so I need new y because I want the model to see what it predicted previously as well. And here is counter. What was counter for? Okay, so counter. So in the first one, I have x and the y. Well, y is u here in this case, but that u was received from RK4, which I don't want. So I'm replacing it with the predicted u that I got. So I'll show those with numbers too, just so we can see. And then once counter is 1, once I take out that, replace that RK4 u value, then I just regularly concatenate it without needing to replace anything. And yeah, so here I just keep the theta and the theta dots and everything like that. So let me show what's happening here with numbers. Let's do, where do I put it? U model, U. We'll put it right here. RBD. But actually, I also want to see what the next state is. What's up right here? Okay, and let's go to the model too. Where is the model? Okay, model. Okay, so here is the model, transformer GPT-2 model that I used. I did change the model a bit, just some functions. So in the previous video for the train, it had all this like indices and all that, but I'm just passing all the predictions since I just want the last one. It was much easier. Also for the combine, I did change it. So I'm not working with batches, but I didn't want to change the whole code structure that I originally had, so I'm adding that extra dimension. And here, if this. So once I replace it, so initially it's xy, but once I xy, 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 but once I replace that last y, it's going to be xy, xy, x, and it's going to be xy, xy, x, and so on. And so what this does, it makes it so that it retains that xy, 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 if that makes sense. So once I have 2 points, or once I add that new state, this will be getting applied. But with only the first state, then it just skips to this. And here in the previous video, I'm just stacking the x and the y and adding a new dimension. So this should be 4 dimensions, and then this turns into 3 dimensions where I flatten it, and by flattening it, while using view, I interweave the xy's, which I will show. And yeah, so you know what, I'll also put an import IPDB here. Maybe the set trace. Is that where am I? I guess I'll also add one. I guess I'll also add one here. Import IPDB.setTrace. Okay, so now let's do Python test 9. But I don't want to test that many numbers. So let's go from 4 to, I don't know, 15. And then just do 0, 3. So since the min start is 4, it has to be less than 4, so I'll just set it as 3 here. So that's the constant. So I'm only going to test in context 0, 1, 2, or 1, 2, 3. Or 0, 1, 2 since. Okay. And yeah, that should be it. So let's check it out. Okay, so we are in line 109. Right, this is where it's interweaving. So in this first one, right, there's no in context happening, so it should just be 1 and 1. So we'll do xb dot shape, ysb dot shape, right? So I'll do that, and I'll even print out the numbers, ysb. Okay, and I do have a notepad here, just in case I wanted to put stuff in there. So iteration 1, no in context, and even then it doesn't matter. So I guess. So this is iteration 1. So this y, or technically u, is from RK4. And yeah, there really wasn't any need for me to even include it, but I did just because I need the same shape. But I could have just made it 0, 0. Because when it makes prediction on XB, it's not able to see the future vectors, or the, yeah. And so now let's do C, which goes to line 140, and here I'll just see what C shape is, right? It should be interweaving it, right? And I am Yeah, so should be that here, C shape. I'll even save that too. And if I do C, I'm now here. So let's see what the upred was. So upred was that, but I only keep the one where that last x was doing it. So if I do print u, right, I keep that first one. I don't care about the y. And yeah, so this is the predictions here. And so what's happening now, since I want to use this prediction here for here, I'm replacing it. That's what this if counter is doing. Because if I didn't, or also let's also see the new x. Yeah, so this is the next states that's happening here. Okay. So that's that new x, and what are they talking about? Yeah, so let's say I have this y, right, that y predicted. I need to replace it or else it's going to be x, y, y, x, y, x, y, y, x, since I'm adding the new state, which wouldn't make sense. But what if I do it for like x, y, and then the new state x, and then this y after it? It wouldn't make sense because that y is correlated to that first x. So that's why I'm doing x, y, or x, y predicted, or technically u, and then that new state x, and then I'm just going to keep that prediction done on x, and I don't really care anything after that, so that's why I'm going to add 0, 0 at the end, just because it has to be the same shape. And yeah, that new shape is what's happening here, right? Since I'm going to be having x, y, x, I need to first make sure to add it so that xb and xy have the same shape, or else I can't be like stacking them and stuff. So let's see what's happening there. So we'll do C, right? And this is iteration 2 now. And so let's do xb dot shape. So this should be 2 now, right? And then ysb dot shape should be 1, right? Because I just replaced it. Yep. I'll even copy this here. Iteration 2. Okay, and I'll do I'll even print it. Right, ysb. Right, so it's that new one. The original was negative 39, but now it's the predicted that we had gotten. So I'll see that too. And we'll do zs.shape, which would be 4. And it is. And we'll do zs. I just added the 0, 0s because I need them the same shape to stack. And that's that. And now, do I need to show more on this? Let's see, I'm trying to see if I have to show more. So xv, yeah, so it's x, y, x, and then now it's, and I guess I could show more. So where am I? Return predictions. So let's see. We're at test 9, and we'll do what prediction was, upred was, right? It was this, and print u, right? And I'll even see what the next state is, new x, right? New x, and okay. So that's that. So negative 38, 19, negative 32, this. But I only care about this prediction, so that's what I'm keeping, which is negative 32. Right, that's what u is, and then I use that to get the next state. And yeah, I'll do it one more time. So at 109, let's print out xb.shape, ysb.shape, and then xb, ysb, and that's that there. Let's do iteration 3. Okay. Iteration 3, and let's do C, shape, ZS. Okay. ZS. Now I'll do C again. I'll do U underscore bread, which is that. And then we'll do print U, which should just be keeping that negative 31. And yep. And we'll print out what was I gonna print out? Oh, that new x. Okay. And so far, we could even see like what x data context is right now. Alright, so it's this, we'll go over the numbers right now. Alright, that's what I'm giving the model. So and or I could also just actually no, I'll just do x data context. Okay. So let's check what's happening a little further. It's kind of a mess. Okay. Now hopefully you guys can see. Okay, so let's see what's happening here. So in this first iteration, with no in context, I have 1, 1, 2, 1, 1, and right here this wire, aka u, is from the RK4, right? But I didn't really need it since it's just doing prediction on this one, and then this comes after, and I'm only parsing it to keep the value done on that last state given to the model. But here's more information on it. Here is ZS stacked, right? So it's that X state and then that RK4 U value, Y, U. And then this is that UPRED. So UPRED is, it gives a prediction for each vector here. So for the X and the Y. And I only keep the one done on that last X, which is only one in this case. And what I'm going to do next, I'm going to replace this Y with my predicted Y, because then it wouldn't be able to fit anywhere else. So it's X, and then my predicted Y, and this can be X. And this is my new state here, so it's going to be technically, for ZS, it's going to be negative 0.5425, and then it's going to be negative 38, and it's going to be negative 0.4708 with this. And it's going to be at the end 0, 0, since I need the same shape for YS and XS. Which you'll see here, right? So it's for the ZS, it's negative 5 point. Okay. Where was I? Okay, let's bold these, right? So this is negative 5.425, which is the same as that, and then it's the predicted Y or predicted U, which is negative 38, and then it's that new state here, right? Gets added here, and then it's 0, 0, and I'm only keeping the prediction done here to get the next state, and so on and so on. And yeah, that's what's happening here. Yeah, that's what's happening here. And so in the next iteration, let's look at ZS. So it's negative 5, that negative 4, right? Which was here, negative 4, that latest state. And then this is that predicted U that I got here for this second iteration. It gets added there. And then the new state was this. It gets added here. And then it's 0, 0. And yeah, that's what's happening. So I just replaced that first Y with my predicted Y or U. And that's what's happening. And then so you can see X data context is negative 5, negative 4, negative 5, 4, negative 4, 7, negative 4, 0. And so you have negative 5, 4, negative 4, 7, negative 4, 0, and then that new one, which is negative 3 here. And yeah, so that's what the model's doing, right? It's starting from an index and it's just predicting further and further. And that's how I'm plotting it, and that's how I'm calculating the total energy, right, by using potential plus kinetic done here. And yeah, so that's that. I kind of want to show how it looks like with in context. But in context, okay, I actually don't know if how, or I guess I could see here. Let's see what context is. Okay, context. Okay, so this is 1, so nothing yet. Let's just go and see. Oh, actually, it's gonna be so many because it has to go to 90 states. But yeah, so the in context would be the same thing. So it'd be the same thing as this initial one, but it's gonna have another X, Y previously, and I'm still just keeping this prediction. And yeah, that's pretty much what it is. So it would just be like, yeah, so it'd just be the same as this, but with another X and Y on top, and yeah, with another X and Y on top. But I'm only keeping the prediction done on that last X state, and I'm still replacing that Y value, but the model still gets from that last prediction. to 90 states. And the way I'm making sure that all the points for total energies constant or the same is by slicing it here. Where do I slice it? I'll slice it here. So when I slice it here, if it's at 20, then it goes to the end. But let's say I have a context of 2, then it would still make it so that it starts at that specific starting index. So that's why I'm slicing. So it'll always be the same number of points. So let's say the starting index is 20. Even if I give it in context, it's still going to start from 20th index to the end when calculating total energy. And yeah, calculating total energy is summing the total energy for each state and then adding it to the correct index in the array. And I think that's pretty much it. I could show the numbers since I can show the numbers since I am saving it to a text file. So let me just run it real quick. But okay, just gonna run it real quick. And I keep seeing this error. It's kind of bugging me. I just canceled it. It didn't crash. I just keep seeing this error. Creating sensor from this NumPy. Let me just fix this real quick. Line 1. Oh, line 71. Torch you. Okay, maybe I should just wait. Actually, let me do like 2 seconds. I'll just cut it out. Let me see. Okay, so it's line 71. Torch you. Okay, it's line 71. Well, I changed it now. It's line 72. Can't read it. Convert to a tensor. Okay, so I'm guessing it's the U. What is U? Type. U. Okay, U. Oh yeah, it's just a scalar. So honestly, I don't even need to pass the array. I could just pass the value. Okay, I think that should be it. Oh no, no. Okay, doing too much. Okay, now it's good. So where is that iteration log? Okay, let's delete that then. Let's run it real quick. So yeah, it usually runs for 64, but I changed it just so it's faster to see. And hopefully this video will finish soon. Wait, 64? No, I don't want that many. Yeah, so the 64 means it's creating 64 lines, but let's do 5 lines. Let's do 5 lines. Oh, sorry. I keep making too many mistakes. Okay. We're just gonna evaluate this and end the video soon. So yeah, for the outer loop, it's going through all the indexes, and for each index, it's going through context 0, 1, 2, 3 for that starting index. And here, not enough numbers with sampling, so then it resets. And don't worry about this graph. It's just a small pool. I'm going to run it for that really long, for more points, more lines. So let's check it out. And so, yeah, out of iteration 1, right, I have this starting index. Here I just did it to 0.3. So I guess for this one it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 points, and then there's all from like, it was all from 4 to 15, and yeah, the value range, and then it's like, what did I just say? 6, 1, 2, 3, 4, 9, length 9. So it's gonna run that middle loop 9 times, and then this is the RK4, and so it's gonna start at the 4th one. So 1, 2, 3, 4, 4, right? So it's gonna, the model is gonna predict 4, and then it's gonna go all the way to the end, but it just sees that first one. All these next states are all from the model, and then from in context, it's gonna go from here, right, and then all the way to the end, and then from here, and then all the way to the end. But for total energy, I'm just calculating it from here to the end, even though I gave it these in context. So yeah, that's why I need to calculate RK4, so I could have gave it previous states, known states. So yeah, so it starts at index 4, right? Index 4, this for context 1, so just that starting index. And you see here that it's 0.54 for one context, and then 0.54 for the next context, 0.54. So this is after slicing. So this is what I'm giving the model to calculate total energy. But if I would actually give it the before slicing for context 2, it would have the previous one. So it would have from, so with context 2, if I start from 0.54, it's actually going to have here to the end, but I only slice it from here to the end. Um, so yeah, as you see, adding in context is changing it a little. So this is 0.54, and then it's 0.4707, 05, 403 or 402, 64, and yeah, even the total energies are different, right? Not by a lot, but in context it's changing it little by little. So here's that. This one for adding the context is doing that, and then 2 in context, or technically I put 3 here. I'm putting 1. So 1 in context, I just means like starting state. So that's what that is. That's why it says 1 in context when it's actually technically 0 since it's just a starting state. But, yeah. And yeah, look, it all starts from the same. The values, predicted states, future predicted states are all different. And this is the energy, so adding it to the array here. And yeah, that's our starting index for it. And then the next starting index is 5. Right, 5, and then I restart from 1 context, 2 context, 3 context, right? So for that point, for that same line, I'm now doing it at 5, and so now I have, right, 0.47, that's where it's starting, and this is now the energy, so 190, 192, 191, and this was what it was before the energy, and then with these 2 energies, I just add on top of it, right? And that's what that's happening. Right, so this is 2, 2, and then I get 190, so now I get 4, 12, and the last one was 2, 4, now I get 192, and then it's 416, and then it was 223 plus 191 is this. And so then I get to the next starting index, which is, right, 9. Right, and do 1, 2, 3 again. The number of constants is always constant. And yeah, now it's 0 0.2, 0 0.2, 0 0.2. There's the new energies happening here. And yeah, it's going to keep going that middle loop until we go through all these start indices. And so that one was what, 9, 8, 9, I don't remember. And so let's go to the second outer loop. Wow, that was a lot. Okay, second outer loop. Right now I only have 2 starting indices, and I calculate the new RK4. This one now is at like negative 2.78, and then negative 4.4. What was the previous one? Yeah, negative 0. So this is a whole new line that I'm going to be testing it on with different numbers, starting indices. And so now with this one, it's just 2 starting points, so that middle loop is just going to iterate twice. And yeah, for that first one, it's the 8th one, so 1, 2, 3, 4, 5, 6, 7, 8, so 2.4, and then 1, 2, 5, 6, 7, 8, so 2.4, 5.7, right? 2.4, 5.7, and now this is the energy for that, and yeah, that's the energy for that, actually. Where was I? Sorry. So the energy is higher because, well, we're starting at a bigger x, not here. And so, yeah, so 2.4, negative 2.4, negative 2.4, that's where we're starting 612 energy, 612 energy, 612. So very similar for in this case, regardless of how many in context. But like I said, I'm going to train it with more in context. Right now it's just a quick example of 3 with like 5 lines. Forgot me lines for the outer loop I did. And so, yeah, so it adds to the previous one. So the previous one was, the previous one before the new loop was 1055. Now I add 612, so it's this, right? And the previous one was like 1068. I get my new loop, now it's this. This was the previous energy, and then I get this one, now it's this. And I go to the next in context, next starting index, and, right, it's all starting. Oh, I got confused. I thought I messed up. I was looking at the wrong one. I was looking at these 2. But this is the next starting, right? So these are all the same. Yep. And these are all the same. Yeah, 5.8. And this is the energy, right? So energy got added to this previous one, so now it's this. And now this is the energy for 2 in context, or 1 in context technically, which is this. And then, yeah, this to this, and then this plus this equals this. And yeah, I'm going to keep doing the same thing for, in this case, 5 outer loops. So it's 5 different lines, but I'm going to do 64 lines with much more in context. Time is 0.9. This is just a little bit of time. And yeah, so the reason why the energy is high is because it's just very little time. If it went to 0.9, it'd be approaching 0, but this is probably approaching like some not that close to 0 since it's not that many. And yeah, so that's the code here. Everything seemed to add correctly, looks correctly. But if you guys see anything off or weird, just let me know, and I'll be sure to look at it. I will also post once I'm done with the initial. I'll also get the log file, or actually I could even get this log file, so you guys could check the numbers to see that it all makes sense. And yeah, if you have any questions or anything, let me know. And thank you. Wait, am I missing anything? Just want to double check. No, I don't think so. Okay, writing and then I just log it. Okay, and then post modem just in case. Like I always use it when something crashed. But anyways, that's it. Thank you.